Hello guys. So I'm Sakit Kumar Jha, and today I'll be taking a session on OSI models in computer networks. So I'll be taking the session and elaborating you on the topic of OSI model. What are the functionalities of OSI model? What are the main functions and what are the layers in OSI model? So basically, what is OSI model? So OSI model stands for International Organization of Standardization. This is also called a model for open system interconnection. The OSI model has 7-layer architecture, which was developed in 1984. Uh, the OSI model was developed to reduce the design complexity, and most of the network are organized as a series of layer or levels, each one built upon its below it. So the basic idea of the OSI model architecture was to divide the whole process or divide the whole design into small pieces for better functioning and better maintenance and etc. So each layer adds service provider by lower layer in such a way that the highest layer is provided has a full set of services. Now after this, uh, what are the basic elements of OSI model? In a OSI model, each layer has some basic elements. So the basic elements of each layer is services, protocols, and interface. So services are nothing but a set of actions that a layer is. So services is a set of actions that a layer offers to another higher layer. After that comes a protocol. Protocols are nothing but a set of rules. If I explain you in layman language, so in your colleges, you might be having some protocols or some rules set up to maintain some decorum. So this is simple, as simple as that. Protocols are some set of rules to maintain the integrity and dignity of the data. Now, interface is nothing but it is a channel through which two layers will communicate to each other. Now, after this, we'll see the 7 layers of the OSI model. So first comes the physical layer, then the data link, network, transport, session, presentation, and lastly, the application layer. So the following 7 layers are divided into two categories. Basically, the first, second, and third layer, that is physical, data link, and network layer, are network supported layers. Okay, but the fifth, sixth, and seventh layer, session, presentation, and application layer, are user supported layer. Now, remaining transport layer is the layer that links both the network supported layer and the user supported layer. So after this, so this is a basic architecture of device A and B. How data will be transmitted from device A to B. So first comes the physical layer. What is the physical layer? So physical layer is nothing but it is the layer, the lowest layer of all. It is responsible for sending bits from one computer to another. So this layer is not concerned with the meaning of bits and deals with physical connection to the network with transmission. The layer will always transmit the data in the form of bits. That's the simple meaning of this statement, if we say that. So if a sender A is sending some short of data to B, so source A is sending some data to source B, so it will be sending those data in the form of bits, that is zeros and ones. Now we come on the functionalities or functions of physical layer. So the first is representation of bits. As I said, it will always stream in bits. It will send the data in the form of bits. Now data rate, at what rate or what speed the data should travel from source A to source B, this will is called the data rate. Means it is, in a simple terms we can say it is bits per second. So how many number of bits will be transmitted from source A to source B per unit second. Now after that comes the synchronization. So it possesses a functionality that is synchronization, which means the data transmitted from source A will be exactly received at source B. Means if we are sending 1 to 3, the data will be received as 1 to 3. If we send 3 packets, it will receive 3 packets. So this is known as synchronization. Now interface. Interface is nothing. The physical layer defines the transmission interface between devices and transmission medium. Okay, so after this, another functionalities in physical layer is line configuration. So what type of configuration does the physical layer follows or possesses? So it follows both point to point and multi-point configuration. Now some of the famous topologies or important topologies through which we can connect the physical layer to other layers of the OSI model is mesh, star, ring, and bus. Uh, After that, what are the transmode modes that physical layer defines the direction of transmission between two devices will be? It might either be half duplex, full duplex, or simplex. Now it simply deals with baseband and broadband transmission. Now after this comes the second layer, which is the data link layer. Now data link layer is responsible uh, for transmission of data in the form of frames. Now frames, as I said, is nothing. So what data link layer will do is it will receive the data in the form of packet from the network layer, and uh, it will frame the data. uh, Here comes a concept of framing. It will frame the data in frame the data, the packet of data, into smaller frames. It will divide it into smaller frames and then transmit it to the next layer. So it will receive the packet of data from the network layer and it will divide it into frames, then it will transmit it to the physical layer. It possesses good functionality. That is important functionality is error controlling is done easily in this layer. Error controlling is very easily done in this layer. Error detection bits are used by the data link layer. So for error controlling, we use error detection bits in this layer. Now functions, as I said, some of the main functions of data link layer are: first, the framing. Framing is nothing but when you receive a packet of data, we divide it into smaller frames. Frames are nothing but a stream of bits received from network layer into manageable data units. Now physical addressing is also done in data link layer. So physical addressing, the data link layer adds a header in front of in frames in order to define physical address of sender and receiver. So what physical addressing means is the data link layer will add um, a header where the physical address of sender and receiver will be kept in the frame if the frames are distributed to different systems on the network. Okay. Now it has another functionality that is known as flow control. It has error control. Now what is flow control? Flow control is a mechanism to avoid fast transmission and running slow, running a slow receive by buffering. The extra bits is provided by flow control. Now flow control is something that, just suppose if you are the sender and I am the receiver. So you send me 5 bits at a time, but my capacity is to receive only 2 bits at a time. So what will happen is you will send more number of bits and I will only be able to receive 2 bits at a time. So there will be a situation of traffic jam. For layman term, let me get into it. So I hope everybody drives a bike or car. So whenever we are driving, we go. So there are single lane. So what the lane capacity is only one vehicle at a time. But we if we insert two vehicles at a time, there will be a bottleneck situation. So jam will occur. Similarly, so it has a better mechanism of flow control in data link layer is present. Now error control is also present in data link layer. Error control is achieved by adding a trailer at the end of the frame. So it is nothing but let me show you. So this is a frame. Just take it as a rough diagram. I'm not good with it. So this is a frame. What we do is we add a header IP here. Header, this is the main message, and this is the tailor. So it is header message. Let me make it like this: message, and this is the header. Okay. So I hope you don't mind with my diagram. I'm pretty much bad at it. So after this, so the last functionality that the data link layer possesses is access control. What is access control? Protocols of this layer determines which of the device has control over the link at any given time. So if suppose access control, you will have been learning it in the OOPS concept. So it is nothing. Access control is, we have a key, okay, a key to a locker, but the key can only be accessed by a certain person. So that is what, not everyone can access the key. So that is what access control means. So it is simply a set of protocols in this layer in such a way that it will determine which device can control, will have the control over the link at any given time. Okay, so this is what we need. There are two parts in data link layer. Basically that is divided into two parts: logical link control and media access control. So this, I'll tell you what is it. Logical link control is the upper layer of the two data link layer, essential for communication between devices. So this is essential for communication between devices. Let me raise this. So it is now, yeah. So logical link control layer is the upper layer of the two, mac and logical, but it is the upper layer. So it is essential for communication between devices. It provides support connection oriented and connectionless. So it will provide you support connection oriented and connectionless, that is TCP IP and UDP. I hope you guys know it. Now Mac, what is Mac? We all know Mac is media access control. It is the lower layer. Okay, it is responsible for providing a method for station to gain access to the medium. After this, the third layer in the OSI model is the network layer. So what is network layer? Network layer is a layer that routes this signal through different channels from one node to other node. Okay, so it acts as a network controller. It manages the subnet traffics. It decides by which route route the data should take. It divides outgoing messages into packets. Now, so we receive outgoing messages from the above layer of the network layer, that is the fourth layer is transmission. So we receive the network, we receive the data. So it will divide the outgoing data into the form of packets. Okay, some of the main functions of network layer are: it translates logical network address into physical. So it will translate your logical address into a physical address. Routers and gateway operates in the network layer. Mechanism is provided by network layer for routing the packets to final destination. Okay, connection services are provided, breaks largest packet into smaller packet. So we can say this, we receive a huge packet of data. So what the network layer does is, it will divide the huge packet of data into smaller packets of data. Okay, okay, and then it will route the packet to the data link layer. Now the fourth layer is the transport layer. Now, as said, transport layer is nothing but it is a transmission medium that will connect the L1, L2, L3 to L4, L5, L6, L7. That will connect the network data link and physical data link and network to session, presentation, and application layer. This is the layer that will connect both the network support and the user support layer. Okay, it decides if data transmission should be on parallel path or single path. So this is the layer responsible for deciding the path on which the data will be transmitted. It receives message from the session layer above it, converts message into smaller units, and passes it on to the network layer. So what is the basic functionality is, it will receive the message on the above layer. Above the transmission layer is the session layer. So it will receive the message from the session layer. It will convert the message into smaller units, and then it will pass to the network layer. Transport layer breaks the message into smaller units so that they are handled more efficiently by the network layer. So this is a basic thing. Now service point addressing is done here. Segmentation is done. Reassembling. What is segmentation? A message is divided into segments. Okay. A huge message is divided into smaller segments. Then a sequence number is allotted to every segment. After allotting a sequence, it will send to the different next layer. Then the next layer, after receiving all the segments, it will combine, reassemble the message, reassemble all the segments to convert a large segment or the actual message. Now even the transport layer has a flow control, error control mechanism. This layer, flow control is performed end to end. In this layer, the flow control is performed end to end. Error control is performed end to end in this layer to ensure that complete message arrives at receiving transport layer without any error. Okay. So what it will check is, it will just simply check that the complete message is received at the receiver end without any error. Error connection is done through retransmission. So what is the method? If suppose we have detected an error, so we will find a mechanism to correct it. So we will retransmit those segments of data or those packets of data to correct the error. Now the fifth layer is this session layer. Session layer is uh, a layer that manages to synchronize the conversation between two different applications. So what does session layer do is, session layer will always manage and synchronize the conversation between two different applications. Uh, it will also transfer data from source to destination. Session layer stream of data are marked and resynchronized properly so that end of the message are not cut and data loss is avoided. So what happens is, the session layer stream data are marked and are resynchronized. It will be resynchronized. It is synchronized, but we again need to resynchronize it properly so that end of the message should not be cut and the data loss is avoided. Now functions, some of the functions of session layer is dialog control. This layer allows two systems to start communication with each other in half duplex or full duplex. Okay, so it will allow two systems to communicate with each other by using either the half duplex method or the full duplex. It provides synchronization. This layer allows process to add checkpoint, which are considered as synchronization points into stream of data. So suppose I'm transmitting a data, a huge amount of data. So a checkpoint is created to suppose from A to B, I have to send the data. In middle, we have created two checkpoints. So the data traveling from A to B through either half duplex or full duplex, when it reaches the first checkpoint, it will be checked that the whole message is uh, receiving as it is sent or there is some error. So the synchronization of the message will be checked. Okay, example, if a system is sending a file of 800 pages, adding checkpoint after every 50 pages is recommended. This is ensured that 50 pages is successfully received and acknowledged. This is beneficial at time 2 of crash, as if a crash happens at page number 110, there is no need to retransmit 1 to 100. Okay, so this is the reason why we create checkpoint. Okay, uh, the primary goal of the layer is, so the primary goal of the presentation layer, this is the L6 layer. L6, the presentation layer. The primary goal of this layer is to take care of the syntax and semantics of the information exchange between two communication systems. Okay, it will check the syntax and semantics of the information exchange between two communication systems. Presentation layer takes care that the data is sent in such a way that the receiver will understand the information and will be able to use the data. Okay, functions of presentation layer. As some of the functions of presentation layer is translation, encryption, compression. Now we'll look into each of them. Now translation. What is translation? Before being transmitted, information in the form of characters and numbers should be changed in bit stream. So translation, you just take it in a simple way. It's that it is converted from a human language to a machine level language. Okay, natural language to a machine language. So that is what translation basically means. The languages, characters and numbers will be converted into bit streams. Encryption. What is encryption? Encryption is one of the most important things that the presentation layer provides. uh, Encryption is to maintain the secrecy, encrypt the message, to maintain the secrecy and dignity of the message. It carries out encryption at the transmitter and decryption at the receiver. So whatever message I'm sending will be encrypted, and the receiver will decrypt the message. Only the receiver can decrypt the message. So through this, no any third party or no any the third party can invade into my message or change my message. Now, what is compression? Compression is it carries out data compression to reduce the bandwidth. We compress the data so that the bandwidth of the data is reduced. Okay, so that the data to be transmitted. Okay, it is important in transmitting multimedia such as audio, video. So, have you ever transmitted a video or an audio, but on WhatsApp we transmit a video? So sometimes it shows no, we can't send this video as it is above the limitation of the MB that are fixed by the WhatsApp group. So what we do is we compress that video. We compress and make it in lesser than that limit so that it will easily be sent. Now the last layer is the application layer. The last layer of the OSI model is the application layer. It is the topmost layer, transferring of field distribution. The result of the user is also done in this layer. What is this? The transferring of files distribution. The result of user also done in this layer. Mail services, directories, service, network, resources, etc. and are services provided by application layer. This layer mainly holds application program to act upon the received and to be sent data. Okay. So what in simple terms we can say that application layer, by application layer what you understand is a layer through which user can interact with the system. Okay. Now some of the main functions of application layer is mail service, directory service, file transfer, access and management. So this layer provides the basics for email forwarding and storage. Directory service. This layer will provide access to global information about various services, file transfer, access and media management. Management. It is standard mechanism to access files and manage it. Okay. Okay, now some of the famous and most important protocols that the application layer follows is HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol, SMTP, Simple Mail Transfer Protocol, NFS, Network File Services, NVT, Network Virtual Terminals. Now, as we come to the conclusion, I'll tell you some of the merits and demerits of the OSI model. So, starting with the merits. So OSI model distinguish well between the service, interface and protocol. So if you remember in the beginning, I said you that it has three basic elements: service, interface and protocols. Okay, so in the OSI model we can distinguish very well between these three. What are the services, what are the interfaces, and what are the protocols need to be followed. Protocols of OSI models are very well hidden. So whatever the protocol of the OSI models are, as we have seen in the previous slide, these are protocols for an application layer. So these are very well hidden so that it is not visible to the whole environment or a um, whole person, those who are accessing it, so that the dignity or the dignity is maintained. Protocols can be replaced by new protocols as technology changes. Yeah, obvious. Uh, it is just say as we are upgrading the protocols or updating the protocols. So suppose in previous, let me take an example of ATM. Just take an example of ATM. So previously ATM used to take 50 to 15 to 20 seconds to for one transaction. So by the change of certain protocols, now it takes only 5 10 seconds to process one transaction. So this is an upgradation. Similarly, protocols can be upgraded as the technologies will be upgraded. Okay, technologies will change. Supports connection oriented services as well connectionless. So it will support both TCP and UDP. Now some of the demerits of OSI model is OSI model was deceived before invention of protocols. Fitting of protocols is tedious task. It is just used as a reference model. Now, what does that means? Model are devised before invention of protocols. So this model came before the invention of protocols that were used in this model. Fitting of protocols in each and every layer is very difficult task for a person. It is just used as a reference model. So nowadays it is just used as a reference model. So by this, I'll be ending my today's session. I hope you all guys understood. Thank you.